Good morning students, welcome to ALPHORES e-learning botany classes. In yesterday's session we discussed about androecium, parts of a stamen. Yes or no? Sir, anthers are of two types. Yesterday I told anthers are of two types. What are they? Dehiscence anthers and monothecous anthers. Yesterday we discussed about this Dehiscence anthers. Now go for next one. What is sir? Monothecous anther. What is sir? Monothecous anther. Sir, this is a monothecous anther. What is sir? Monothecous anther. Monothecous anther. See the diagram. How many anther lobes are there? One anther lobe. Only one anther lobe is present. Sir, if two anther lobes are present, then it is connected by connective tissue. Here only one anther lobe is present, so connective tissue is absent. What is absent? Connective tissue is absent. Okay. Therefore, monothecous anther, what it contains? Monothecous anther contains one anther lobe. How many anther lobes it contains, sir? One anther lobe it contains. Here connective tissue is absent. What is absent? Connective tissue is absent. Connective tissue is absent. Okay. In yesterday's session I told each anther lobe contains how many microsporangia? 2 microsporangia. Sir, what is another name for microsporangia? Microsporangia, also called as pollen sac or pollen chamber. Yes or no? Pollen sac or pollen chamber. Therefore, in monothecous anthers also write one anther lobe. One anther lobe having how many microsporangia? 2 microsporangia. Having how many microsporangia? 2 microsporangia. Sir, as a monothecous anther is having 2 microsporangia, monothecous anther is called as bisporangiate. Who is called as bisporangiate? Monothecous anther. Which anther, sir? Monothecous anther. Called as what? Bisporangiate. Bisporangiate. Why we are calling monothecous anther as bisporangiate? Why we are calling monothecous anther as bisporangiate? As monothecous anther, as it contains right 2 microsporangia. As it is having how many microsporangia? 2 microsporangia. Monothecous anther is called as bisporangiate. Now listen the statement. At maturity, when at maturity the 2 microsporangia of the same anther lobe, only one anther lobe is there, yes or no, of the same anther lobe gets fused. What gets fused? The 2 microsporangia of same anther lobe gets fused and forms how many theca? Forms 1 theca. Forms how many theca? 1 theca. Okay, this happens when? At maturity, right? Therefore, at maturity, what happens, sir? 2 microsporangia. 2 microsporangia of same anther lobe. 2 microsporangia of same anther lobe gets what happens? Fused. Okay, right? 2 microsporangia of same anther lobe gets fused to form a what, sir? Theca. To form a theca. Sir, this monothecous anthers seen in the case of China rose. What, sir? China rose, Hibiscus rosa sinensis. Scientific name of China rose, Hibiscus rosa sinensis. Sir, this China rose belongs to which family, sir? Malvaceae family. Belongs to which family, sir? Malvaceae family. Sir, in case of this China rose, this anther, I am speaking about this anther. Anther is kidney shape or reniform, R-E-N-I, reniform or kidney shape. Okay. Therefore, in which plant, sir? China rose. How the anther is? Reniform, reniform, reniform or kidney shaped, what? Reniform or kidney shaped anther. Reniform or kidney shaped anther, right? Now listen here. So take Dehiscence anther, right? Dehiscence anther, Dehiscence anther. Take a monothecous anther. What's that? Monothecous anther, monothecous anther. Okay, right? Sir, in Dehiscence anther, number of anther lobes. I am speaking about what, sir? Number of anther lobes. Number of anther lobes. Number of what, sir? Anther lobes. Number of anther lobes. Sir, in Dehiscence anther, how many anther lobes are present, sir? In Dehiscence anther, how many anther lobes are present, sir? Better to write here. It will be easy for you. Number of what, sir? Anther lobes. Number of anther lobes. Dehiscence anther is having how many anther lobes, sir? 2 anther lobes. Monothecous anther is having how many anther lobes? 1 anther lobe. Right. Next one. Sir, number of what, sir? Microsporangia. Number of microsporangia. Sir, Dehiscence anther is having 4 microsporangia, whereas monothecous anther is having how many microsporangia? 2 microsporangia. Yes or no? Right. Sir, number of microsporangia. Number of what, sir? Number of microsporangia. Number of microsporangia in each anther lobe. In each anther lobe. Sir, whether it is Dehiscence anther or monothecous anther, number of microsporangia in each anther lobe. How many, sir? 2. How many, sir? 2. Right? Go for the next topic. What it is? Fixation of a filament to anther. Sir, filament is fixed to anther. Filament is fixed to anther in 4 ways. In how many ways, sir? 4 ways. Therefore, fixation of a filament to anther, right? How many ways or how many types? 4 types or 4 ways. What are they? Number 1. First one is base fixed. What is the first one, sir? Base fixed. Base fixed. Second one is dorsy fixed. Dorsy fixed. Dorsy fixed. Third one is adenate. 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 Okay. And fourth one is versatile. 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 Okay. Go for the first one. What it is, sir? Base fixed. Base fixed. What it is, sir? Base fixed. Sir, in these 4 types of fixations, base fixed is common. Who is common, sir? Base fixed is common. Base fixed is common. Sir, what is the meaning of this base fixed, sir? See the diagram once. Sir, this is a anther. This is a anther. Okay. Sir, this is the filament. Filament is fixed to anther at the base. See the diagram. What is fixed? Filament. To what? Anther. Where? At the base. Therefore, filament fixed to anther at the base. Filament fixed to anther. Filament fixed to anther. Where, sir? At the base. Filament fixed to anther at the base. This is basally fixed. I already told you this is common. Yes or no? So this basally fixed can be seen in the case of Fabaceae family. Okay, right? Solanaceae family, Brassicaceae family, Liliaceae family. Okay, right? This is basally fixed. Now go for the second one. What it is, sir? Second one is a dorsally fixed. What is the second one, sir? Dorsally fixed. Dorsally fixed. Now see this diagram. Sir, in this diagram, how many anther lobes are there, sir? Only one anther lobe is there. Therefore, this is a monothecous anther. Which anther it is? Monothecous anther, right? Now listen. Filament is fixed on the dorsal surface of the anther lobe. See, sir, this is the filament. This is the filament. Filament fixed to anther on which surface, sir? Dorsal surface. That's why we are calling it as dorsally fixed. What we are calling it as dorsally fixed. Okay. Therefore, what is the meaning of dorsally fixed, sir? Filament fixed to anther. Filament fixed to what, sir? Anther. Filament fixed to anther on dorsal surface. Filament fixed to anther on which surface, sir? Dorsal surface. Okay, right? Sir, dorsally fixed example is a China rose. What is the example for dorsally fixed, sir? China rose. What is the scientific name of China rose? Hibiscus rosa sinensis. Hibiscus rosa sinensis, right? Now go for the third one. What it is, sir? Adenate. Adenate. Now listen here. Sir, this is a anther, sir. This is a anther, right? Now listen the statement carefully. Sir, this is a filament. What is this one, sir? Filament. Filament is attached to anther from base to apex. See the diagram. Filament is attached to anther from base to apex. Base to apex becomes what, sir? Adenate. Okay, right? Therefore, adenate filament. Filament fixed to anther. Filament fixed to anther. Filament fixed to anther from where to where, sir? From base to apex. From base to apex. Sir, adenate example I am writing Mycelia. What it is, sir? Mycelia or Mycelia. Second one is Neelambo. Neelambo nucifera, lotus. Neelambo nucifera, scientific name of lotus. Okay. Therefore, adenate seen in the case of Mycelia or Mycelia. And second one is a Neelambo nucifera, that is lotus, right? See, go for the fourth one. What it is? Versatile. Fourth one is versatile. See, this is filament. The tip of the filament is pointed. The tip of the filament is pointed. Sir, this tip of the filament, it's pointed, no? It is attached to anther. It is attached to anther on the dorsal surface at one point. Attached to anther on the dorsal surface at one point. Okay. By which what happens means this anther swings freely in all the directions. What is swinging freely? Anther is going to swing freely in all the directions. Here the pen is filament, the chalk piece is anther. Sir, anther, what it contains? Pollen grains. When this anther is going to swing like this, it releases the pollen grains into the air. Releases pollen grains into the air. Therefore, now pollen grains are released in the air. This air carries the pollen grains from one place to another place, right? We are discussing fourth one, that is what, sir? Versatile. Just now I told tip of the filament is pointed, right? Tip of the filament. What, sir? Tip of the filament is pointed. Okay, right? Sir, tip of the filament is pointed. Okay, and this filament tip attached to what, sir? Anther. Attached to anther. Where, sir? On dorsal surface. On dorsal surface at a point. At a point. So what happens? So anther swings freely. Anther swings freely where? In the air, releasing pollen grains. Releasing pollen grains. Releasing pollen grains into the air. Releasing pollen grains into the air, right? We are discussing versatile, right? Now what are released into the air, sir? Pollen grains are released into the air. Pollen grains are released into the air, right? Therefore now where are the pollen grains? Air. Now who is carrying that pollen grains? Wind. Okay, so pollen grains. So pollen grains are carried. So pollen grains are carried by whom, sir? Wind. It means here transfer of pollen grains with the help of wind. Yes or no? So which pollination, sir? This is a wind pollination. Which pollination, sir? Wind pollination. Wind pollination is called as a anemophily. Wind pollination is called as what, sir? Anemophily. Anemophily. Therefore, versatile fixation is seen in plants in which wind pollination takes place. It means pollination with the help of wind. Okay. Therefore, versatile fixation. What it is? Versatile fixation. Versatile fixation, right? Seen in what? Versatile fixation seen in plants, right? In which what takes place, sir? Wind pollination takes place. The plants in which wind pollination takes place, in such plants, right, versatile fixation is seen. Therefore, versatile fixation seen in plants which right, in which wind pollination takes place. Okay, now I am writing examples for versatile fixation. Example for versatile fixation: grasses. What, sir? Grasses. For grasses I am writing examples: rice, wheat, maize. What, sir? Rice, wheat, maize. I already told you what is the scientific name of rice, sir. The scientific name of rice is Oryza sativa. What it is, sir? Oryza sativa. This is a scientific name of rice. Therefore, rice, wheat, maize, these are grasses in which you can see versatile fixation, right? Go for the next topic, dehiscence of anther. What it is? Dehiscence of anther. Sir, dehiscence means break. Sir, in anther, what are present? Pollen grains are present. In anther, what are present? Pollen grains are present. When anther reaches maturity, the anther has to dehisce. The anther has to break. Then only the pollen grains can come out. Yes or no? Right. Therefore, at maturity, anther dehisces. At maturity, anther dehisces and releases what? Pollen grains. At maturity, anther dehisces and releases pollen grains. This dehiscence of anther is by 4 ways. Therefore, anther dehisces in how many ways, sir? 4 ways. 4 types. Anther dehiscence. How many types, sir? 4 types. What are they? Number 1, longitudinal dehiscence. What is the first one, sir? Longitudinal dehiscence. Second one is transverse. What is the second one, sir? Transverse dehiscence. Transverse dehiscence. Third one is valvular dehiscence. Valvular dehiscence. And the fifth one is porous dehiscence. What is the fifth one, sir? Porous dehiscence. Longitudinal dehiscence, transverse dehiscence, valvular dehiscence, porous dehiscence. Go for the first one. What it is, sir? Longitudinal dehiscence. What it is? Longitudinal dehiscence. For example, right, this is a anther, sir. What is this one, sir? Anther. See this one carefully. Sir, at maturity, this anther dehisces longitudinally. How the anther is dehiscing? Longitudinally. See, it is dehiscing longitudinally. This is longitudinal dehiscence. Okay. Now go for the second one. What it is? Transverse dehiscence. Now see this one. Sir, this is anther, sir. Okay. This anther is dehiscing transversely. See how it is dehiscing, sir? Transversely it is dehiscing. This is transverse dehiscence. Now go for the third one, valvular dehiscence. Sir, this is a anther, sir. Now you can see the anther wall, W-A-L-L. What is this one? Anther wall, anther wall. On anther wall, valves are formed, V-A-L-V-E, valve. I think you can see these valves. Sir, this is a valve. Okay, opening. Right. Through this valves, the pollen grains comes out. This is valvular dehiscence. Therefore, on the wall of anther, what are formed, sir? Valves are formed, by which the pores comes out. This is valvular dehiscence. Now go for the last one, porous dehiscence. Sir, this is anther, no? At the tip of the anther, pores are formed. Through these pores, P-O-R-E-S, through these pores, pollen grains comes out. See, this is anther. This is tip of the anther. Okay, in this tip of the anther, pores are formed. I think you can see the pore. Through these pores, P-O-R-E-S, pollen grains comes out. This is which dehiscence? Porous dehiscence. Okay. Therefore, anther is dehiscing in how many ways, sir? 4 ways. Okay. Right. What is the first one, sir? Longitudinal dehiscence. Here, anther dehisces longitudinally. Sir, this longitudinal dehiscence is common. Which one is common, sir? Longitudinal dehiscence is common. Longitudinal dehiscence is common. Sir, longitudinal dehiscence is seen. Longitudinal dehiscence is seen in the case of Datura. Longitudinal dehiscence seen in the case of Datura. Now go for transverse dehiscence. Here anther dehisces transversely. Sir, transverse dehiscence is seen in the case of China rose. Transverse dehiscence seen in the case of China rose. Now go for valvular dehiscence. Right. On the wall of anther. On the wall of anther, what are formed, sir? Valves formed. Valves means nothing but openings. Valves are formed. What are formed, sir? Valves are formed. Valves are formed. What are formed, sir? Valves are formed. Okay, right? Therefore, valvular dehiscence. On the wall of the anther, what are formed? Valves are formed. Sir, valvular dehiscence, I am writing the example. Valvular dehiscence, example is Casita. What it is, sir? Casita. Sir, this Casita, it is a incomplete stem parasite or incomplete stem parasite or partial stem parasite. It is incomplete. It is incomplete stem parasite or partial stem parasite. Incomplete stem parasite or partial stem parasite. Now go for the last one. What it is, sir? Porous dehiscence. Sir, porous dehiscence means this is the fourth one, right? Porous dehiscence. What, sir? At the tip of anther. At the tip of anther, what are formed? Pores are formed. Sir, these pores, where they are formed, sir? Tip of the anther. So we are calling these pores as apical pores. Which pores are they are? Apical pores. Okay, right? Porous dehiscence is seen in the case of solanum. Porous dehiscence is seen in the case of what, sir? Solanum. In the case of solanum, right? Now listen here. Sir, we are discussing dehiscence of anther, right? Dehiscence means nothing but break. At maturity, the anther has to dehisce. Yes or no? Anther has to dehisce. Sir, dehiscence of anther, it may be either intrors or extrors. What it is, sir? It may be either intrors. What it is? Intrors. It may be either intrors or extrors. It may be either intrors or extrors. Intrors or extrors. Now see here. Sir, in this diagram, right, this is right, corolla. What is this one, sir? Corolla. This is corolla. Whereas this center one, this is what, sir? Gynoecium. What it is, sir? Gynoecium. Gynoecium. Sir, all these are what, sir? All these are stamens. Now this is anther. See here. See the diagram carefully. Sir, anther dehisces towards gynoecium. Yes or no? Anther is dehiscing towards gynoecium. This is intrors. Therefore, what is the meaning of intrors, sir? Anther dehisces towards gynoecium. Therefore, intrors means inside, no? Who is present towards inside, sir? Gynoecium. Therefore, anther dehisces. Anther dehisces towards gynoecium. Anther dehisces towards what, sir? Gynoecium. This is intrors. Sir, this intrors seen in the case of datura. Intrors seen in the case of what, sir? Datura. Seen in the case of datura. Okay, right? Now go for the second one. What's our extrors? What it is, sir? Extrors. See the diagram? Sir, in this diagram, what is this one, sir? Corolla. Corolla means made up of petals. What is this one, sir? Gynoecium. This is gynoecium. See here. Anther is dehiscing towards corolla. Anther dehisces towards corolla. This is what, sir? Extrors. Extrors outside. Who is towards outside? Corolla, but not gynoecium. Yes or no? Therefore, anther dehisces. Anther, what, sir? Dehisces towards. Anther dehisces towards corolla. That is nothing but towards petals. This is called as what, sir? Extrors. Extrors. Example for extrors is China rose. What is the example for extrors, sir? China rose. China rose. This is about dehiscence of anther. Sir, anther dehisces either towards the gynoecium, that is intrors, or dehisces towards the corolla, that is towards the petal, that is extrors, right? Stamens are of two types. Stamens are of how many types, sir? Two types. Based on length of stamen with respect to length of petals. It means now we are comparing the length of stamens with the length of petals. Okay. With respect to length of petals, based on length of the stamens, right, stamens are of how many types? Two types. Therefore, based on what, sir? Based on, based on length of stamens. Based on length of stamens. With respect to what? With respect to length of petals. With respect to length of petals. Okay, therefore based on length of stamens with respect to length of petals, stamens are of how many types? Two types. Stamens, how many types, sir? Two types. What are the two types of stamens, sir? First one is inserted stamens. Inserted. What it is, sir? Inserted stamens. Inserted stamens. Second one is exerted stamens. What is the second one, sir? Exerted. What is the second one, sir? Exerted stamens. What is the second one? Exerted stamens, right? Exerted stamens. Exerted stamens, right? Go for the first one. What it is, sir? Inserted stamens. Inserted stamens. Name itself indicates inserted. It means they are present inside the flower. Yes or no? Sir, why they are present inside the flower? Because the length of the stamen is more or less. Length of the stamen is less than the length of the flower. So automatically stamens remains inside the flower. Yes or no? Therefore, stamen length. Stamen length. Right, less. Stamen length less than length of flower or length of petal. Okay, right. Sir, whose length is more? Petal's length is more. Whose length is less? Stamen's length is less. So automatically what happens, sir? Stamens remains. Stamens remains where, sir? Remains inside the flower. Stamens remains inside the flower. This is which stamens, sir? Inserted stamens. Sir, inserted stamens, example, datura. Datura. Number 2, dolichos. What and what, sir? Datura and dolichos, inserted stamens. Now go for the second one. What, sir? Exerted stamens. What is the second one, sir? Exerted stamens. Go for exerted stamens. Exerted stamens. Sir, what is the meaning of exerted stamens, sir? Name itself indicates exerted. It means stamen comes out of flower. What came out of flower? Stamens came out of flower. Why, sir? Because the length of the stamens more than the length of petals. Therefore, what, sir? Stamen length. Stamen length more. Stamen length more than what? Length of petals. Than length of what, sir? Petals. So what happens? Stamens comes out of stamens comes out of what? Flower. Stamens comes out of flower. What came out of flower? Stamens came out of flower. Okay. These are which stamens? Exerted stamens. Exerted stamens, example. Exerted stamens, example, acacia. What are the example for exerted stamens, sir? Acacia. With this, we completed dehiscence of anther and types of stamens based on length of stamens with respect to length of petals. Right? Stay home, stay safe. Right? Thank you.